All right, this is the next unit on the Pythagorean Theorem, which actually is in our book is the last part of 7.3. But typically I make a whole unit out of it because there's a lot of things you can do with it. So the first thing we're going to do in this section on the Pythagorean Theorem is talk about a right triangle. And we're specifically going to label all the sides. The longest side, which is opposite, directly across from the right angle, is the hypotenuse. And then the other two sides are the legs that are opposite the two acute angles of the right triangle. As many of you know, in a right triangle we have a special relationship between these sides, the hypotenuse and the legs. And in particular, in a right triangle, the sum of the squares of the two legs is equal to the square of the hypotenuse. Thus, the formula a squared plus b squared equals c squared. So this is formally known as the Pythagorean Theorem, named after the Greek mathematician slash, he had all kinds of things that he did, but he was a mathematician. He also had his own religion, believe it or not. But Pythagoras, who was from Greece. Anyway, what we're going to do is look at some problems where we're solving for the missing side. So what this Pythagorean theorem will mostly be able to do is allow us to do this, to take two sides of the given triangle and find the missing third side. So in a situation where we know two sides and we're trying to find the third, Pythagorean theorem is optimal. So find the length of the missing sides where A, B, and C are the sides of a right triangle and C is the hypotenuse. One leg is A is 12, the other is A is 9, and then B is 12. So our two legs are A is 9, B is 12, and there's our hypotenuse C. By the way, typically they'll make side A opposite vertex A, and side B will be opposite vertex B, and side C will be opposite vertex C. Anyway, if we go Pythagorean theorem, we will get 9 squared plus 12 squared equals c squared. Or if you forgot the formula, it's a squared plus b squared is c squared. So it's just all computation from here. 9 squared is 81. 12 squared is 44. The sum of those two numbers is 225. And the square root of 225 is 15. So the hypotenuse of this particular triangle would be 15. Let's do another example where in this example the legs are 5 and 12 units and the hypotenuse, again, is the missing side. So again, we will go a squared plus b squared is c squared. So 5 squared plus 12 squared is c squared. 5 times 5 is 25. 12 squared is 144 equals c squared. So now if we add these up, it'll be 169 is the sum of 25 and 144. And of course, working backwards again. And I didn't really point that out a lot on the first one, but how do you solve if you got c squared? Well, you can take the square root of c squared as c. So in this case, the square root of 169 is 13. By the way, the square root answers the question, what number multiplied by itself is 169? Well, 13 times itself is 169. In all these examples, though, most calculators are equipped to just take the square root. By the way, if you are desperate need of a phone, a calculator, you can simply open up your calculator on your smartphone and then just simply turn your phone sideways, and it will automatically make a scientific calculator, and it will have the square root button, the sine, cosine, log, and all those important functions. So again, if you're desperate, just take your smartphone, open up the calculator, and then turn it sideways. There's also calculator apps you can download on the internet onto your phone. There's also calculators that are built in on the computer, so if you want to just go on the internet. So there's many options for that. All right, example 3. Suppose that the hypotenuse of a right triangle is 26 units and one leg is 10 units. So I'm going to make a sketch. So the hypotenuse is 26 units and one leg is 10. Now remember, the hypotenuse is always C. Now A and B are basically interchangeable, so I'm just going to make A 10, so B will be my missing side. So we will set it up as 10 squared plus B squared equals 26 squared if we take the Pythagorean theorem again. A squared plus B squared, C squared. So it'll be 100 plus B squared equals 676, I believe. I have to check that one. Let me pause here. Yes, that is correct. I just wanted to make sure that that was correct. I didn't have a calculator with me. Wasn't prepared. But anyway, just wanted to make sure the numbers are right here. And now what we'll do is, this is a little different than the first two we did. Basically, you just, squared, added, and took the square root. But since we're solving for the leg, what we have to do is isolate the B. So we actually have an extra step involved. We have to subtract 100 from both sides. And that will give you 576. And now you have the B squared isolated, so you can do the square root principle. And that'll give you 24 units is the length of that leg. Right here is 24. So again, when you solve for the leg, more than likely when you plug in, you'll square. Then you have to isolate A or B, whichever one you are solving for. In this case, we're doing B. And then you should be able to take the square root. Just a subtle difference in how you solve when solving for the leg as opposed to solving for the hypotenuse. Okay. The next question is example 4 from your notes. And the question asks, it's kind of like a reading problem. It asks, an empty lot is 120 feet by 50 feet. And then it asks, how many feet would you save walking diagonally across the lot as opposed to walking length and width? Which would be, I could find that right now if we just walk, like pretend it's a park in the middle of town, and you walk, down this street 120 feet and up this street 50 feet, you would walk 170 feet. But suppose you went straight diagonally across the park, what distance would be that? What would that distance be, and how much would you save? How much distance would you save doing that? Well, again, this is a right triangle. We can assume that the corners of the empty lot or park are right angles. So we can go C squared equals A squared plus B squared. And that will be 50 squared plus 120 feet squared. 50 squared is 2,500 and 20 squared is 14,400. So when you add these together, that's 16,900. So if you go the square root of both sides, you'll end up that value is 130 feet. So walking straight across the park, it would be 130 feet. Walking length and width, it would be 170. So you would actually save 40 feet. And you probably have done this several times when you could, you're in an area and you save distance, you wonder how much you save. You know, you can walk this way, but you think, well, I'm just going to cut straight across the park and it's quicker, and it probably is, but now you know how much you save when you do that. So you could actually make a Pythagorean theorem problem out of it. Anyway, the answer would be 40 feet. Okay, example 5, and this is, again, most of these are the same as what in my notes. You'll probably realize at this point sometimes I have different examples than my PowerPoints. In this one, we have a diagonal brace, that's the support brace, on a wall that has a height of 10 feet, and the base of the wall is 24 feet. So the question is, how long does the brace, how long do we have to make the brace? Well, again, using Pythagorean theorem, we would have 24 squared, 10 squared, and c squared. 24 squared would be 576. 576. 10 squared, 10 times 10 is 100. The sum of those is 676 equals c squared. So again, if we take the square root, you should discover that that brace needs to be 26 feet in length. And again, here's kind of another carpentry around the house type example. Often that's not that uncommon. In fact, carpenters, when they're building houses, often when they're putting in walls and ceilings and things that require a lot of right angles, they'll actually measure out 3 feet, 4 feet, 5 feet, the 3, 4, or 5 right triangle, just to make sure they have a right angle. So that's kind of a quick trick that you may see some carpenters do, just to make sure their angles are right, using 3, 4, 5 right triangles, or they may even measure the length of the diagonal. Which actually brings me to the next example. If you were to say build a shed in your backyard, and I've done this before, of course I had help. If you get a kit from a place like Home Depot or Lowe's that provide those, you'll get all the parts of the shed along with the instructions. But in the instructions of the shed, what's neat is you have all the diagonal tests and they have all the measurements. So as you can see in this example, John is going to make a wall for a shed in his backyard. The wall is 8 feet by 16 feet. John wants to measure the length of the diagonal of the wall to make sure the wall's corners are right angles. So as you can see in the diagram, it's 8 feet and 16 feet. So if we do the Pythagorean test, 8 squared plus 16 squared, it's 64 and 256, and those numbers come out to 320 if we add them. So if we take the square root of both sides, the square root of, if we go to the nearest tenth, the square root of 320 is about 17.9 feet. So that's what the diagonal would have to be. Now, like I said, when you buy these kits from Lowe's or wherever, the instructions should have diagonal tests for all the walls, the floor, the ceiling, and even the roof. You know, all the rectangles that you basically construct and then you put them all together to make the shed will have these diagonal tests. And it does help to make sure your corners are right angles. And you check both diagonals, actually. So, this is kind of a neat little trick, but that is very convenient when you're designing walls and things of that nature. Okay, one last example I want to do, and I want to do one where you solve for the leg again. So what I have here in the picture is a building, and you have a 50-foot ladder resting against the window ledge, which is 40 feet above the ground. And we want to figure out how far from the edge of the building is the ladder. So that will be this side. So remember I said a and b are interchangeable. Let's say we make that b. So a squared plus b squared is c squared. Again, this would be assumed to be a right angle. It would be 40 squared plus b squared, our unknown, plus 50 squared. 40 squared is 1,600. 50 squared is 2,500. Again, we have a situation on this side. We need to get the b squared isolated before we take the square root. So we will subtract 1,600 from both sides, which now gives me b squared is 900. And the square root of 900 is 30 feet. So, see if you have any questions on that one. Basically, that is all the examples I'm going to do. I did most of them out of the PowerPoint. There were some I didn't do, so feel free to go through and work those examples. And also, there are good examples. Actually, for this situation, I have a handout that I'll post on D2L. But I believe there are some problems out of the book on Pythagorean Theorem. And there are some web assigned problems. So there should be opportunities to practice this. Just continue the work in Chapter 7 and email me if you have any questions. The next unit will be on trigonometry.